everybody, welcome to Algebra 1, Lesson 56. We're talking about addition of rational expressions. So with this kind of addition, remember it's when you're adding terms that don't have common denominators. And when you have variables in your denominators of your fractions, we've learned about how you have to find the common denominator by going by prime numbers, taking the prime factors as often as they're used as a factor, and you make the greatest common denominator, the least common denominator, you're out of that. So, sorry, excuse me while I turn. So when we are adding expressions that have addition in the denominator, you have to look at that expression, you have to look at that as one factor. It's not one term, but it is one factor. So we can put parentheses around it to show that it itself is being multiplied as a unit. So here's a factor, x plus y, then this is the factor of this fraction, x. So what's their greatest common factor here? For this, hold on one second. I'm saying the wrong term. Sorry guys. What's their least common multiple? Excuse me. What is their least common multiple? So for this one, our term is x. For this one, our term is x plus y. So this is the factor here. This is the factor here. So their least common multiple for x, and x plus y would be x times x plus y. So, in order to create that here, what am I missing? Well, I'm just missing this term. So I have to multiply this fraction by, I'm going to write it down here, x plus y over x plus y. You can't just multiply the bottom, you have to multiply the top as well. Because this, when the fraction is the same on the top and on the bottom, equals 1. So in order not to change the value of this fraction, I have to multiply it by something that is the same on the top as it is on the bottom. So down here on the bottom, you get x times x plus y. So you get x times x plus y. And here on the top, you have a times x plus y. Now, you have over here, in order to get the same term, you have to multiply this one by x to get x times x plus y. So you have x times x plus y. And since you have to multiply the top by the same thing, you have b times x. Now remember, you can combine it like this. Just add together your numerator. A times x plus y plus bx over x times x plus y. Okay? Now there's actually several ways that you can write this that are all correct. So sometimes this is what gets confusing because you might see the answer written out a little differently than this, but it actually is the same thing. So let me show you some of the other choices of ways you could leave your answer. Sorry guys, I'm getting hair in my mouth. So you could leave your answer just like this, or you could multiply and distribute to your parentheses to get rid of them. So I can multiply a times x plus a times y, and then I have plus bx over x squared plus xy. Now I've gotten rid of all of my parentheses, and that's all I have left. Normally, that's what you will see is some form of not having the parentheses. So you might see it like this, or you might see it where they just simplify the numerator, but leave the denominator like this. Lots of different ways to rewrite this. And of course, you can move around these terms as long as you keep the sign in front of them. So when I'm reading off of answer or something like that, make sure you listen carefully and just make sure you have all the parts, even though they might be a little different, okay? Okay, let's move on to the next one. I think with these kinds of problems, just the more practice you get, the better, because sometimes it takes a little extra practice to make sure that you capture everything that we're doing. Okay, so this one is 4x plus a over a plus b plus cx. So what would be the least common denominator? Well, this term is a plus b. So for this denominator, it should be a plus b, then this one is x. So there you go, a plus bx. So this particular fraction I have to multiply by x so that it becomes a plus bx. This one I have to multiply by a plus b. So whatever I multiply the denominator by, I have to then multiply the top by. So this top becomes 4x squared, because 4x times x is x squared, plus ax. I'm going to go ahead and extend my line. My final denominator is going to be a plus b times x. I'm going to leave my denominator in parentheses. Now on this one, I have x times a plus b, so now I have to multiply that by c. But I'm going to go ahead and distribute as I write my answer. C times a, ac, c times b, bc. And that's my answer. I could have also left this as plus c times a plus b, leaving a plus b in the parentheses. That would also be the same thing. You should always check your numerator to see if there's any terms that you can combine. And here there are not, so you could just leave it like this. Inside your book, or in your book, you'll see this is basically what they left the answer as. All right, now let's try another example. I have a plus b over x plus c over m plus d. So here we have to treat d like it is a whole number. So to make a whole number a fraction, what do? You put it over 1. So we don't have to really worry about that one when it comes to creating your least common multiple, because 1 times anything is itself. So just focus on these two. So its only factor is x, its only factor is m, so the least common multiple would be xm. So this first fraction I have to multiply by m over m to get xm. This one, to get xm, I have to multiply by x over x. This one I have to multiply by xm over xm because it doesn't have either one of them. So my ending fraction, it will have the denominator of xm or mx, either way, doesn't matter which order you put that in. This numerator will be am plus bm, or you could have ma plus b, mb, doesn't matter, plus cx plus dxm. Okay? And that's it. Let's do the last one together. So here for this one, I'm going to do a little squiggly line so you see the difference between those two. All right, I have a over b plus c minus x plus d plus m over k. First things first, let's change this x to a fraction so we don't get confused. But we don't have to worry about it when we create our least common multiple. So this one, b plus c is a term, and is a factor, and k is a factor. So their least common multiple would be b plus c times k. So for this one, I just have to multiply it by k to get b plus c times k. So this becomes a k minus, well, for this fraction, I have to multiply it by the whole thing, b plus c times k. So it will be x times b plus c times k. I'm going to come back to this in a minute. Plus, now this one has k, and d plus m is one term. So this one is d plus m times b plus c. Now I'm going to simplify my terms as much as I possibly can. So over here, ak, that's fine. So it's going to stay AK minus, so now I have negative x times b. I'm going to do this over here because we're going to have to change a few things. Negative x times b is negative xb. Negative x times c is negative xc. And then this is all times k. So that would be negative x, let's do this over here. Negative xbk minus xck. Just like that. Then you have plus, then on this side, b times d plus b times m. So I'm going to multiply b times d and then b times m. Then I have c times d and c times m. All over b plus c times k. Whew, that's a lot, right? You can choose to leave it like this, or you could multiply it all out. Either way, it's all the same, okay? Same answer. All right, now I want you to go and do your practice on page 208. Okay, you should be back from your practice. Your first one, letter A, you should have gotten mx minus bmy plus y times c plus d. So they didn't use the distributive property in the answer, and that's perfectly fine. All over my should be your denominator. Letter B did use the distributive property, but if you left it more like this and did not distribute, perfectly fine. 5b squared plus cb minus ax plus bx plus cab plus cb squared, all over a plus b times b. So now, normally after this, from now on, I will probably just leave it inside the parentheses and not distribute, just so that hopefully your book will also have the same kinds of answers and there won't be as much confusion. Okay, I know there was a lot that we went over in this time, so I went a little bit fast. If you feel like you're unsure about how to do this concept and you want some extra practice, or you want another video, you want me to explain a couple more problems, let me know and I would be happy to do that, okay? So have a great day, guys. Bye.